The universe began with a bang, the Big Bang. In a fraction of a second, it expanded from an infinitely dense point to a sea of energy. This energy cooled, forming the first fundamental particles. Among these were hydrogen and helium, the simplest and most abundant elements. Forged in the Big Bang, they became the building blocks for everything. Imagine the early universe as a hot, dense soup of these elements. Gravity pulled these elements into massive clouds. These clouds birthed the first stars, igniting with nuclear fusion. The early universe, dominated by hydrogen and helium, was simple, but within these elements lay the potential for everything we know, and it all started with a bang. Stars are more than just twinkling points of light in the night sky. They are immense cosmic furnaces. Deep within their cores, under unimaginable pressure and heat, hydrogen atoms are fused together, creating helium and releasing a tremendous amount of energy. This process, nuclear fusion, is the engine that powers stars and the source of their brilliant light and heat. But stars don't stop at helium. As they age, they begin to fuse helium into even heavier elements, like carbon, nitrogen, and oxygen. These elements, essential for life as we know it, are created in the hearts of dying stars. Think about that for a moment. The very elements that make up your body, the air you breathe, and the ground you walk on were all forged billions of years ago inside stars. The heavier the element, the higher the temperature and pressure required to forge it. Massive stars, much larger than our sun, can create elements as heavy as iron in their cores. But even these stellar giants eventually exhaust their fuel. When this happens, the balance between gravity and nuclear fusion is broken, leading to a spectacular and violent event, a supernova. A supernova is one of the most powerful explosions in the universe, briefly outshining an entire galaxy. When a massive star runs out of fuel, its core collapses in on itself, triggering a shock wave that rips the star apart. This explosion is so powerful that it can fuse elements even heavier than iron, such as gold, silver, and uranium. But supernovae are more than just destructive forces. They are also the universe's grand recyclers. The explosion scatters the star's enriched material, including all the elements it forged during its lifetime, across vast distances. This stardust, enriched with the building blocks of planets and life, becomes part of the interstellar medium, the vast clouds of gas and dust that permeate galaxies. Imagine these supernovae as cosmic gardeners, seeding the universe with the elements necessary for life. Without these explosive events, the universe would be a much less interesting place, devoid of the heavy elements that make up our planet and ourselves. We are, quite literally, stardust. Billions of years ago, in a quiet corner of the Milky Way galaxy, a cloud of stardust began to collapse under its own gravity. This cloud, enriched with the remnants of countless supernovae, contained all the elements necessary for the formation of a solar system. As the cloud collapsed, it began to spin faster and faster, forming a rotating disk of gas and dust. At the center of this swirling disk, the sun ignited, bursting into life and bathing the surrounding disk in light and heat. Over millions of years, the dust particles in the disk began to clump together, forming larger and larger objects. These clumps eventually grew into planets, asteroids, and comets, each with its own unique composition and history. Our own planet, Earth, formed from this swirling cloud of stardust. The very same elements that were forged in the hearts of ancient stars now make up the air we breathe, the water we drink, and the ground beneath our feet. We are, in a very real sense, children of the stars. Section 5. Life's Building Blocks, a Cosmic Inheritance. The elements forged in stars and scattered by supernova didn't just form planets, they became the building blocks of life itself. Carbon, the backbone of all life on Earth, was created in the hearts of dying stars. Oxygen, essential for respiration, was also a product of stellar fusion. Think about the iron in your blood, carrying oxygen throughout your body. That iron was forged in the core of a star that exploded billions of years ago. The calcium in your bones, the nitrogen in your DNA, the phosphorus that helps your cells function, all of these elements were created in the fiery furnaces of long-dead stars. We are, in a very literal sense, made of stardust. The atoms in our bodies were once part of distant stars, scattered across the cosmos and then drawn together by gravity to form our planet and ourselves. This profound connection to the cosmos is a reminder that we are not separate from the universe but an integral part of its grand story. Section 6. Life on the Edge, Extremophiles and the Search for Alien Life. Our search for life beyond Earth often begins with looking for environments that resemble our own. But life, as we are learning, is incredibly resilient and adaptable. On Earth, we have discovered organisms called extremophiles that thrive in conditions that would be deadly to most other life forms. These organisms have been found in scalding hot springs, in the frigid depths of the ocean. The existence of extremophiles has broadened our understanding of where life might exist elsewhere in the universe. If life can thrive in the most extreme environments on Earth, it stands to reason that it could also exist in the seemingly inhospitable conditions found on other planets and moons. Places like Mars, with its subsurface ice, or Europa, with its subsurface ocean, suddenly become more promising targets in our search for alien life. The discovery of extremophiles has revolutionized our understanding of life's possibilities. Section 7. Beyond Carbon. Imagining life as we don't know it. Our search for extraterrestrial life is often focused on finding evidence of life as we know it, life that is carbon-based and requires water as a solvent. But what if life elsewhere in the universe has evolved along a completely different path? What if there are life forms that are not based on carbon at all, but on other elements like silicon or nitrogen? Silicon, like carbon, has the ability to form complex molecules. It is also abundant in the universe. Could life have arisen on other planets using silicon as its building blocks? Could there be creatures out there with silicon-based biochemistry, breathing an atmosphere of chlorine or methane? The possibilities are truly mind-boggling. We must be careful not to let our own limited perspective on life blind us to the potential diversity of life in the universe. The universe is full of surprises, and the discovery of non-carbon-based life would be one of the most profound discoveries in human history. Section 8. Europa Clipper. Journeying to an icy ocean world. One of the most promising places in our solar system to search for life is Jupiter's moon Europa. Europa is covered in a thick shell of ice, but beneath this icy exterior, scientists believe there lies a vast, salty ocean that could potentially harbor life. This ocean is thought to be more than twice the volume of all the Earth's oceans combined, and it may contain the ingredients necessary for life as we know it. To investigate this intriguing possibility, NASA is sending a mission to Europa called the Europa Clipper. The Europa Clipper will orbit Jupiter and make multiple close flybys of Europa using a suite of instruments to study its icy shell, subsurface ocean, and potential for life. The Europa Clipper is a testament to our insatiable curiosity and our desire to understand our place in the cosmos. It represents a bold step in our search for life beyond Earth and has the potential to revolutionize our understanding of the solar system and our place within it. Section 9. Alien Landscapes. Life in the Extreme. Imagine a world shrouded in perpetual twilight, lit only by the faint glow of a distant star. This is the reality on Titan, Saturn's largest moon. Titan is a world of strange and wondrous landscapes, with methane lakes, icy volcanoes, and a dense, nitrogen-rich atmosphere. While Titan's surface is far too cold for liquid water, scientists believe that its subsurface ocean could potentially harbor life. This ocean, like Europa's, is thought to be salty and may contain the building blocks of life. Titan's unique chemistry and potential for both surface and subsurface liquids make it a prime target in the search for extraterrestrial life. The search for life beyond Earth is a search for the unknown. It requires us to expand our imaginations, to consider possibilities that challenge our current understanding of life. The universe is full of surprises, and the discovery of life on a world like Titan would be a testament to the incredible diversity and resilience of life itself. Section 10. The universe beckons, in search of cosmic companions. We are stardust, forged in the hearts of stars and scattered across the cosmos. This profound realization connects us to the universe in a way that few other things can. It reminds us that we are not alone, that we are part of something much greater than ourselves. The search for life beyond Earth is a search for our cosmic companions, for other beings who share this incredible journey through the universe. It is a search that is driven by our deepest curiosities, our desire to understand our place in the cosmos, and our hope that we are not alone. The universe is vast and full of mysteries. The possibility of discovering life beyond Earth is a tantalizing one, a prospect that fills us with wonder and excitement. The journey of exploration has just begun, and the discoveries that await us promise to be truly awe-inspiring.